Oh God, oh God! Trig sub, this time definite, but first we have a game plan. Choose the sub, make sub, and don't forget dx. Algebra and integrate, trig, triangle, and back sub. These are our substitutions down here. Whoa. Our problem, gonna use this one, why? What's our problem? Bam. What's your problem? We're going from 0 to 0.06 of x squared over the square root of 9 minus 25x squared dx. What's next? Boom! We're trying to get it in the form. So we factor out that 25 because we need a 1 in front of the x squared. Then we see that 9 25ths is the same as 3/5 squared, which implies our a is 3/5. So we fit our x with our a, sine theta. Because we had the constant in front of the x squared, that's how we chose our substitution. So let's go get dx. Don't mess with me, you know I got it. It's the 3/5 cosine d theta. We make our substitution. Bam! Put me in, coach. I'm ready to play today. Everywhere I saw an x, I put a 3/5 sine. Everywhere I saw a dx, I put a 3/5 cosine d theta. Now, I know that it's a definite integral, but let's just do that after our integration. So I'm saying I'm leaving my limits, no limit. Let's see what happens after we clean this up. I'm going and I'm squaring things. Sure. Now I'm going to combine some things. I see the 3/5 and the 9 25ths. That's 27 1/25ths, and then the 25s go away inside the integrand. Now, let's go ahead and factor out that 9. Fine. We're left with 1 minus sine squared. That's the only trig identity you ever remember. That's the cosine squared. Oh, that's under the root. Root. But the square root of those squared quantities is going to be 3 cosine blah. But that reduces to, but let me write it all pretty. The cosines cancel, and I'm going to move that 3 out front. That 3 fights that 27. You're a 9. So I have 9 25ths and the cosine's gone. I'm going to take it to the top. I have 9 1/25ths the sine squared theta. How do you integrate that? We have to use our reduction formula. So we do. And that's 1/2 1 minus the cosine 2 theta. Now, that 2 is going to go out front, doubling that denominator. And that's how we get 9 over 250. And 1 minus the cosine of 2 theta. We integrate. When we integrate the constant with respect to theta, we get theta. And then that's minus 1/2 the sine of 2 theta. Dot. Let me rewrite it over here because I need some room. This problem's getting big. So I just rewrote. What's my original sub? My OG sub, x was 3/5 sine theta. That implies that the sine theta is 5x over 3, which leads us to our triangle, because it's opposite over hypotenuse. So I write the opposite over the hypotenuse. Then I use the Pythagorean to get the third side. That third side, that's 9 minus 25x squared. So, now it's an exercise in reading. I need to read off that triangle what my theta is. To find our thetas, we use our inverse functions. The one that's easiest on the eye is the inverse sine. And that's opposite over hypotenuse. Minus, oh, look at that, double angle, boom! Because our triangle's in term of theta and not 2 theta. Let's reduce those deuce. Then I deduce that I have a 9 over 250 sine inverse 5x over 3 minus, that's the sine off the triangle. That's the cosine off the triangle. Now, don't forget, this definitely was a definite integral. We're going from 0 to 0.6. I'm doing upper minus lower. What's upper? 0.6. What's lower? I'm going to squeeze that in there because zeros are killers. Now some interesting things happen. If you don't believe me, check it. Do 5 times 0.6 divided by 3. You're going to get 1. Do 9 minus 25 times 0.6 squared, you're going to get none. That's what's going on here. So what? That term is 0, really 0, and so is that one, because the sine inverse of 0 is 0. So what do we have? We have that 9 over 250. That's the sine inverse of 1, but wait, there's more. You know what the sine inverse of 1 is? That's pi over a deuce. So we deduced that we doubled the denominator, and look at that. It's looking like a Tijuana taxi. So colorful. Box and flower.